Welcome to a presentation on rate and slope. The goals of this video will be to determine a rate of change and also to determine the slope of a line given 2 points. Let's start with some background information. A ratio is a quotient of two quantities. A ratio of A to B is given by the fraction A over B, where A is the numerator and B is the denominator, or by the colon notation A colon B. A rate is just a ratio that indicates how two quantities change with respect to each other. For example, if you have a job that pays $12.50 per hour, that's a rate. The cost of gasoline, $2.55 per 1 gallon. Cost of rent, $850 per 1 month. And gasoline, 28 miles per 1 gallon. Again, I'm writing these in fraction form, but you probably are used to seeing them in this form here. Let's take a look at a situation. Let's say you take a trip from Phoenix, Arizona to Los Angeles, California. You travel 280 miles in 5.5 hours. On the trip, your car consumes 15.8 gallons of gas. If you were to compare the number of miles traveled to the number of hours, the graph of your trip may look something like this. We can see here the rate of change of the miles with respect to time is not consistent. You can see here at the beginning it starts off at a slower rate, then you have a fairly consistent rate here, and then somewhere in the middle it looks like the time is passing but the distance is not changing. This may be where you stop for gas or pulled off the road at a rest stop. What we want to be able to do is find the rate of travel or speed in miles per hour. We also want to find the rate of gas consumption in miles per gallon. So to find the rate of travel or speed in miles per hour, we have to write a rate that compares total miles to total hours. So we traveled 380 miles in 5.5 hours. This is our rate for this trip, but to add more meaning to it, we're going to go ahead and divide or find this quotient. So we'll take 380 and divide it by 5.5. This comes out to slightly larger than 69, but for the sake of an example, we're going to leave it as approximately 69. We're going to leave the units on miles per 1 hour. Notice the value is still 69, but we left the units on there, and this is our rate, and we normally write this as 69 mph, or miles per hour. This is our average rate for the entire trip. If we want to find the rate of gas consumption, again we must compare miles to gallons. So again we traveled 380 miles on 15.8 gallons of gas. So to add more meaning to this, we are going to find this quotient and leave the units alone. So 380 divided by 15.8 is just slightly more than 24. For the example, we'll call it 24 miles per 1 gallon of gas, normally written as 24 mpg. Now I'd like to take a look at this graphically. In blue we have the graph of our trip comparing miles to time in hours. What I'd like to do is take a look at the starting rate, and if I start down here at the origin or the start of our trip, if I go up to 380 miles and over 5.5 hours, of course, I end up here at the end of our trip. But now if I take the rate of 69 miles per hour, and again I start down here at the origin, if I go up 69 miles and over 1 hour, I'm on this red line. And in fact, if I go up 69 miles and again over 1 hour, I'm again on this line. So this rate kind of affects the slant of this line, which is called the slope, which we'll get to in a minute. But keep that in the back of your mind. When we find this rate, we're actually finding how this line will be slanted, which is also known as the slope of the line. Brings us to the slope of a line. The slope of a line containing the points x1, y1, and x2, y2 is given by the change in y over the change in x, sometimes called the rise over the run. So to calculate the slope, we have to find the change in the y-coordinates over the change in the x-coordinate, just like we did for our examples of rate. It is important that we keep this difference consistent. If the numerator is y2 minus y1, the denominator must be x2 minus x1. Let's go ahead and give it a try. Graph the line containing the points -4, 3, and 2, -6. So -4, 3, and 2, -6. So we want to graph the line through those 2 points. That would look like this. And now we want to find the slope of this line. So let's call these the 1's, x1, y1, and we'll call these the 2's, x2, y2. Remember our formula for slope is equal to y2 minus y1 divided by x2 minus x1. So our slope will equal -6 minus 3 over 2 minus -4. Looks like we have -9 over a positive 6, which simplifies to -3 over 2. Our slope is -3 halves. This is telling us the change in y is -3 and the change in x is positive 2. So from this point, if I go down 3 units because the change in y is negative, and I go right 2 units because the change in x is positive 2, you can see I end up on that line. And of course I can keep doing that. If I go down 3 and right 2, I'm still on that line. And in fact, if I was to use the form here that's not simplified, if I started at this point and went down 9 units and over 6 units, I'd still be on that line. Let's try another one. Here we want to find the slope of a line, but they did not give us 2 points. We have to determine our own 2 points. We can pick any 2 points on this line, but we want to pick 2 points where the coordinates are integers. So we may want to use this point here where the coordinates are -3, -2, and maybe this point up here where the coordinates are 3, 0. So let's call these the 1's, x1, y1, x2, y2, and let's calculate our slope once again. So our numerator is going to be y2 minus y1, or 0 minus -2, and our denominator will be 3 minus -3. Looks like we have 2 over 6, which is equal to 1/3. Again, let's test it. Let's start anywhere on the line. Let's say we start at this point here. The change in y is positive 1, so if I go up 1, the change in x is positive 3, so I go right 3, I should be on the line, and I still am. Let's try maybe this point here. If I go up 1 and right 3, notice we're still on that line. We have found our slope correctly. Now, if you know a lot about horizontal lines, you may already know the slope of this line. Let's just assume that we don't. Let's pick 2 points. Let's say we pick the point 1, 3, and let's say we pick the point 4, 3. Again, I'll call these the 1's and I'll call these the 2's. So the slope will be equal to 3 minus 3 over 4 minus 1. So we have 0 over 3. Now, is this 0 or is this undefined? Well, a quick easy way to test it would be to take 0 and divide it by 3 and say, what times 3 gives you 0? Well, 0 times 3 gives you 0, so it actually works out. So our slope is 0, and in fact, any horizontal line has a slope of 0. Let's take a look at one more. Here we have a vertical line. Again, we need 2 points. Let's pick the point -3, 1, and the point -3, -2. And I'll call these the 1's. I'll call these the 2's. So our slope would be y2 minus y1, -2 minus 1, over -3 minus -3. This simplifies to -3 over 0. And we can't divide by a 0. This is undefined. Sometimes they'll call this a line with no slope. Any vertical line has an undefined slope or no slope. Okay, I hope that helps explain how to calculate rate and also how to calculate the slope of a line. Thank you for watching.